and move on. Okay, so now going on to the other one. So this question again, this was another question which was not very simple, but if you look at it properly, it in fact converts in itself in a very simple question, and I'll show you how. So the question is very simple. It says that there is a line like this. Let me just make it better. Okay. So the question actually tells me that you know okay, so I'm coming back to this question. So see, this question is nothing but it says that there is a middle point somewhere, and every 10 meters on either side they have kept some stone and all. So there is a stone here, here. There's a guy who starts off at the center, and the number of stones are odd number. So therefore there is one stone here. Let us say this is your first stone, and this is the second, third, and let's say this is the nth stone. Okay, similarly on this side this is the nth stone. Okay, so since this is odd number of stones, you will have equal number of stones on either side if there is a stone which is kept here. So your total number of stones eventually will become 2n minus 1. Did you see how? The number of stones from here to here is n. Again from here to here is n. So total number is 2n. Now since we are counting this stone twice, so we'll subtract 1 and it becomes 2n minus 1. So ultimately we have to find n. Now see, understand, this guy starts from here. Okay, he goes to this point, picks up the stone, comes back, puts it here. So the distance that he is traveling is actually 10 meters into 2, which is 20 meters. Similarly, if he has to pick up this stone, the distance that he will travel will be 40. So basically he is traveling a distance of 10 plus 40, okay, plus something plus n minus 1 into 10. So that is the distance he is traveling into 2, because for every time he is traveling twice the distance. And now we will see that he also has to cover the same thing on this side, so another 2. So that is the distance that this guy is traveling, correct? So now I'll tell you why I wrote this n minus 1 here. There is a reason behind it. So see, this is the first stone, okay, this is the second stone, so this is n, yeah, but the distance that we are covering for this is nothing but 10 plus 10, 20 meters, right? So I'm sorry, this is supposed to be 20, okay, so 10 plus 10 20 plus 40, like that, this will also become 20, yeah, and then we will only need to use one multiplication here, that is 2, because we are covering the entire distance here. 10 here and 10 here, and again 10 in going back. Okay, so we'll take it out, and it will become 2 into 20, 1 plus 2 plus 3, n minus 1. Okay, but you also have to understand that this thing is happening on the other side as well, and therefore your total distance will be nothing but 4.8 kilometers. We can write it as 4800. Okay, and we have to and divide it, it becomes 2400. Take it off, it becomes 120. That becomes easy. So guys, this is how we will write the formula, and then we'll simplify it again. So if you simplify this formula, it becomes an equivalent of, So we'll add up all these numbers here. So see, eventually what will happen, let me just clean it once and I'll quickly do it again for you. Okay. So it's a simple thing. So you have to break it down. The total distance covered here is 4.8 kilometers. Okay. Now, if I calculate only for one side, the distance covered will be 2.4 kilometers. Now for each stone, he is covering the distance twice. So let us say I only assume that he covers half the distance. So the distance becomes 1.2 kilometers. Okay. So therefore the distances that he will cover will be nothing but 10 plus 20 plus n minus 1 into 10 in meters. And why I am saying n minus 1 into 10 is that let's say this is the nth stone. Okay, so this is the fourth stone. So if I am picking up the fourth stone, what is the distance that I am covering? I am covering 10 plus 20 plus 10 plus 10 plus 10, which is 30 meters. Okay, so which is n minus 1 into 10 because I am picking up the fourth stone. So when I pick up the nth stone, I will actually cover n minus 1 into 10, right? So I will take 10 as common, okay, and then I will get a sum of 1 plus 2 plus up to n minus 1, and I will equate that number to 1.2 because I just showed you how from 4.8 we are reducing it to 1.2 because 4.8 is for both the sides, 2.4 is only for half the side, and 1.2 since for each of the stone the person is covering double the distance, we are assuming he is only covering one side, so we have reduced it to 1.2. Okay, so that becomes 1200 meters if we convert in meters, and the summation of numbers from 1 to n minus 1 will be n into n minus 1 by 2, and we'll take the 2 on the other side, and when we solve this equation, n will be equal to 16. But right at the beginning what we had discussed, the total number of stones is 2n minus 1. So 2n minus 1 is what? 32 minus 1, which will be 31. It's a slightly difficult, slightly tricky question, but if you break it down and if you're good at arithmetic, AP, etc., basically it's not even an AP question. You just have to count it properly, and since the common difference here is 10, so it becomes easier. Now let's move on to the next question, which is other. See, these type of questions used to be asked in CLAT examinations in 2007, 8, 6, those years, and now these questions are no longer the very new kind of questions. And the last two digits, to find out the last two digits of any powered number, it's first very important to understand the concept of power cycle. So every number which ends in any of the digits, the power cycles actually they sort of repeat themselves in a certain pattern. So let us say the power cycle of 7 raised to the power 1 is 7, 7 raised to the power 2 is 49, 7 raised to the power 3 is 343, 7 raised to the power 4 is 2401, and again if you multiply it by 7, so again you will go back to this 7, and then you will, so the power cycle of 7 is 7, 9, 3, 1. That is the power cycle of 7. Now see, any odd number, it in its power cycle it always has this number 1. So let's say 3 raised to the power 2 is 9, 3 raised to the power 3 is 27. Once you get 7, 3 raised to the power 4, again, so you get 1 in the end. So this is 81. So what I am trying to say is that any odd number, it always has this. You can always break it down in a fashion wherein the last digit will be 1. So it's a very good concept, and I will tell you how. So power cycles will tell you the last digit. Okay, power cycles will tell you the last digit. If you have to find out the last two digits, there is a very easy shortcut. So first what we'll do is that we'll convert it in a number which is ending in 1. Alright, so here very quickly what I'll do is that okay, so 7 raised to the power 2008, we can write it as 7 raised to the power 4 into 502. Okay, so 7 raised to the power 4 is 2401 raised to the power 502. So it is ending in 01. So any number which ends in 01, the last digit will be 1 only, irrespective of what happens. Yeah, so the last digit is 1. For the second last digit, you also have to find out the second last digit here, and you multiply this with the last power number here. Okay, so since this is 0, it becomes 0. So the last two digits will be 01, and 01 is the answer. So remember this technique. So if it is an odd number, convert everything which is ending in 1 and then express it as a power of that number. So the last digit automatically becomes 1, and the second last digit will be this second digit here multiplied into the first digit here. And how to do it in case of even numbers and all? See, for 5 it is easy. For all the odd numbers you can use this technique, 7, 9. Okay, for 5 it is easy, either it is 25 or it is 75. So in my next video I will explain it to you how to find the last two digits number in case of even numbers and the numbers which end up in 5. But in 5 you can remember the shortcut, either it will be 25 or 75.